Good afternoon, ladies and gentlemen. Very happy to be here to talk about ESA and sustainability, meaning that ESA has a deep link with sustainability. Indeed, space activities are very much rooted with sustainability. ESA, since decades, is working on sustainability satellites, meaning that space missions in Earth observation are providing very important information and data to better understand the planet, how it is behaving. And in this very moment, in the European Space Agency, a few kilometers far from here, there is a meeting of the Council, which is a meeting that member states are holding 4 times a year. But this meeting is a very important one because it is the last one before what we have as a Council at ministerial level. And the Council at ministerial level is meeting every 3 years to decide about new programs. And I would say that never, like this year, sustainability is very much embedded into the programs that we are preparing for approval by ministers in 1 month, a bit more than 1 month from now, in Germany, in Bremen. All of them address sustainability objectives. And all of them, in a way, are also addressing how to reduce the impact of space activities on the different 3 environments that we have the challenge to face. Yes, because you have been learning for sure since this morning that space has the challenge to impacting 3 different environments. We are not only talking about outer space, we are talking, and we just come out from it, a low Earth orbit, and we are talking about the Earth. And therefore, it is very much embedded into the strategy of the agency to maximize, on one side, the benefits that space activities, and especially the space activities that are led by the agency, are bringing to society. But on the other side, also to tackle the problem, because space so far, or until a few years ago, has been a solution. But now we know, with the increase of satellites in orbit, with the increase of launcher events, it is becoming part of the problem. And this problem is in the 3 environments. It is in the space, where resources are scarce, and we have been learning how to manage scarce resources through circular economy principles, in a low Earth orbit, where the orbit is crowded, and therefore it is putting at risk any type of business up there, and on Earth, where space activities are no different than any other human activity, so they are generating an impact. So, twofold objectives for the European Space Agency. Focusing on Earth, we have to increase the benefits of our space activities, of all the ESA projects, but at the same time, we want to decrease and reduce the environmental impact of those activities. And we have clear pledges that have been done in terms of reduction of greenhouse gases emission. And this is done through a program which is called the ESA Green Agenda, that is deployed since 3 years now, and it is progressing in these 2 directions. What has been the journey of the agency so far? We can recall very briefly how much important have been all the Earth observation satellites for the better understanding of the planet. I'm pretty sure that everybody of you is very well aware of that, so we can know much better the thickness of our ice, the composition of the atmosphere, or the surface temperature, and the level of acidity of the oceans. And at the same time, other satellites, always in low Earth orbit, are providing data and information which are helping us to mitigate and to adapt to climate change. They are helping us to be more reactive and resilient with the crises that have been generated by climate change. And therefore, they can also help key subjects like mobility, farming, or water management, or energy management. But the agency has started, as I said, several years ago to look at also the problems that the space activities are generating and not only the solutions. So starting from 2012, we have been applying life cycle assessment to a selected number of space projects led by the agency. We started with the launchers, but then we have spread around with different satellites, so different space segment, ground segment, and launch segment as well. So these studies have been building up the knowledge that is necessary to understand where the problem lies, where there are the hotspots. In 2016, the agency has been inspired by the ISO standard, has been developing a standard for a set of guidelines for applying life cycle assessment to space system. And since then, we are using those guidelines to perform more and more LCAs. In 2025, we have added the first environmental objective in the ESA Agenda 2025, and then the ESA Green Agenda has been developed a few years later. We have started working with the European Commission to be sure that the PFCR is in alignment with the current practice of life cycle assessment. And we have been developing and populating a database for life cycle assessment where data sets have been collected from all the missions that have been evaluated, and therefore they are at use for the entire community of industry in Europe to perform analysis and see how to improve the situation. Those things are kept alive, they are updated, and I will come back very quickly on that later on. What I've been learning during these years, that there are hotspots all along the chain of the life cycle of a satellite. And here in the picture, you can see only 3 of the environmental indicators that are included in a normal life cycle assessment. And you can see that global warming is, of course, one of those that are classified as a hotspot for the life cycle of a satellite or a space mission, but also the depletion of materials or the ozone depletion. And we have identified in a very qualitative manner for the moment, because it's clear that we need to increase these knowledge bases, what are the major hotspots. And we can see that during the development phase, the design phase, office work and traveling is one of them. During the production phase, we have the testing of satellites, and you can imagine that this is very much energy consuming, but also the use of materials. And then in the launch phase, the propellant is also impacting not only the global warming part, but also the ozone depletion, and we have been hearing about that in the previous session. Of course, during the use of satellites, we have a massive use of data centers, and this is also energy consuming. So we know where we can lever to reduce the environmental impact of space activities. And there are 2 question marks, but I think that you just came out from a panel which was dwelling into the atmospheric impact. That is something that during the reentry is certainly to be further explored. Let's go to the next one briefly to say that ESA is deploying a complete framework to build upon what I've been learning during these last 13 years and go for a real eco-design approach. What we are going to put in place, and this is very recent. First of all, we are going to use the instruments that are already there. So the guidelines to perform an LCA and an LCA database that is already in place. But we want to go beyond that. We want to apply eco-design to our projects. And very recently, an eco-design policy has entered into force in the agency. And one of the pillars of this eco-design policy is in the middle of this wheel graph, and it is an eco-design technical roadmaps. Because to perform eco-design, we have to have available solutions. So we must be able to make a choice between a solution that is less environmentally impacting to the one that is more environmentally impacting. And this is requiring research, development, innovation, and this is what the agency wants to put in place through this roadmap that should be hopefully something that is at European level. So we should again join efforts to make sure that we are developing technologies, materials, processes that are aiming at reducing the environmental impact of our systems. I will really fly over the next one because you have been just hearing the previous panel, but there are a few pillars that it is important to bear in mind altogether about the atmospheric impact from reentries. First of all, we need to share our knowledge, and this has been very much underlined during the panel. We have to put this knowledge in common to be able to progress on it. For sure, common efforts are needed also for the on-field testing, which is very complicated. And beside this, we should put in place simulations. So we can do that on ground. We can simulate what is happening up there on ground, and we can join efforts at putting laboratories together to do so. And finally, of course, we have to improve modeling, because once we have a solid modeling of the reentry and the impact of reentry, we can apply it and evaluate what are the hotspots, in this case, probably materials. If we move very quickly to the next environment, we are talking about in-orbit environment. So we have been talking this morning, my colleague was recalling the policy of ESA about space debris and the charter, Zero Debris Charter, that has now reached 180 signatories. Among them, there are 21 governments, meaning countries that have been engaging and signing the Zero Debris Charter. And I would like to notify you that during this week, the ESA Space Debris Office has published the Space Environment Report 2025, where you can find very useful information about what's going on up there. It is very, very recent. If you look briefly at the Moon and deep space, it was also recalled during the panel that the circular economy is one of the key elements for the future of space. We must reuse, recycle as much as possible, and it is particularly true when we are talking about exploration, when we are talking about cis-lunar and in future cis-Martian activities. So it is very important that we keep that in mind, because bringing materials up there, it is very complicated, it is very costly, and we must develop innovative techniques to develop circular economy, especially for future exploration, if we want to be really sustainable. Let me conclude with the key takeaways from what I have said. Sustainability is deeply interlinked with space, and in particular deeply interlinked with the European Space Agency's activities. The agency is committed and engaged in all the environments to make sure that the future generations can benefit from space the same way we are doing in these times. It is about a transversal effort, and the agency wants to play its role, which is the core role of the agency. So promoting innovation, developing technologies, and applying rules in their procurement and industrial policy rules. Eco-design we have been talking about. This is a key to promote innovation and develop new alternatives that are less impactful on the environment. Circular economy, we have seen that it is very important not only in low Earth orbit for cleaning up our crowded low Earth orbit, but also in future exploration mission. And finally, I have been forgetting to say, but it is very much in the DNA of the agency, that collaboration is central for the success, especially when we are talking about sustainability. And I see in the room many of the more than 100 signatories of the Statement for a Responsible Space Sector, which is a community, a growing community of companies, organizations, academia that are joining efforts, exchange on best practices, and they are progressing for having space more responsible and sustainable in the future. With that, I thank you.